guys, welcome back to 8th grade science with Mrs. Rinker. We're actually going to be starting a new unit, so if you turn in your books to page 62 and 63, you'll see there's a bright rainbow and it says the words light up here. And before we get started on this unit, we're going to make a new foldable, and what you'll need is you will need 3 pieces of white or blank paper and probably like some sort of a stapler of some sort, okay? And it's really easy. What you're gonna do is you're going to take these 3 papers and you're gonna line them up, make them about like this. You're gonna put them kind of like this, where they're not fully in line with each other. And then you're going to take the other ones, which are the back side, which is also like that, and you're going to fold them over like this, and you'll try and make them so they're all nice and even like that. And then you're going to fold it down, okay? Press it down like that. So you've got these flaps, and then you want to take a stapler, and you just want to go ahead and staple the top there. 1, I'm going to do 3 of them. 2 and 3, and voila, you have a new foldable where we've got some different flaps that we're going to be adding to. Okay, so here's mine. You can write the word light on it, probably better than mine. And then if you look at the Google Slides that I've added to this week's post, you can see that there are better graphics than the ones I have in my foldable. But we'll be using that for this whole unit. So if you go to page 63, it says, how do rainbows form? Now you have to log in to McGraw Hill and watch this video called Chasing Rainbows and see what happens there. And then I know it says with a partner. You can do it with a partner if you want to, someone at home. But please do make a list of questions that you could potentially investigate more to find out about rainbows and how they form. And write those questions right here, okay? I'd like you to try to get at least 3 questions about rainbows right here. Next, after that, you're going to turn the page. Now, we have a new STEM module, but we're not going to do that. We don't have time for that. We don't have the resources either. So we're going to move on to the lesson launch. And here's a probe that it says traveling waves. Sound and light both travel by waves. In order to hear sounds or see light, waves must travel from one place to another and enter either your ears or eyes. How do you think these waves travel? Circle the response that best matches your thinking. So we're going to circle which one you think is the best. So here we have A. One needs to travel through matter, meaning only one of them, either light or sound, only one of them. B, neither needs to travel through matter, or they both need to travel through matter. Okay, how do you think sound and light waves travel? One of them travels through matter, none of them travel through matter, or they both need to travel through matter. So what I want you to do right now is I want you to write, I used to think, and tell me right now how you think these matter. Now, when we are done with this unit at the end of the week, we're going to come back and do the but now I know this, okay? So only do this one first. Only do this one first right now. How you think sound and light waves move. At the end of the unit, then we'll come back and do this one, but that's not till the end. Okay, let's go ahead and turn over to page 67. We have, how light travels. We've got these cool looking buildings right here. And we're going to compare now light compared to what we've been learning about with sound waves. So you do want to go online and watch a little video called Amazing Architecture in McGraw Hill. Imagine you're standing on a busy street looking up at the skyscrapers in the photo on the left. What would you hear? Record your thoughts in the box on the left. So what kinds of things would you hear? If you were standing right here, what would you hear? List some things that you would hear. Now, what would you see? If you were standing right here and looking around, what are some things that you would see as you're looking around? Write those right here. You can share your thoughts with a partner and see what kind of similarities you might have with somebody else in your house. Okay, so go ahead and you can show this picture to somebody else in your house. They can be any age, young or old, and see what they think. And go ahead and compare some similarities that you might have to somebody else in your house. Or if you talk to a schoolmate with your phones, you can also do that as well and discuss any similarities that you have with each other on that. All right, the last thing I want you to do for this video section is we want to turn to our CER. And we're only going to fill out our claim today, only our claim. When you look up at a skyscraper, you might see different materials, such as brick, metal, and glass. You might see your reflection in a window or see through another window to people inside the building. You might hear cars moving or people talking. How does light and what you see compare to the sound and what you hear? Use your ideas about light and sound to make a claim about how light compares to sound. So light is similar to and different from mechanical waves like sound by, okay, so right here I want you to tell me something that's how they're similar and how they're different. Light and sound. Light and sound. How are they similar and how are they different? All right, we'll see you tomorrow.